This is the lesson for section 4.3b, day 2. If we look at the diagram that you're given in problem 1, you're asked to use the Pythagorean theorem to find the length of the missing side. We're given two sides, the two legs of the right triangle, but we're not given the hypotenuse, which is the side opposite the angle C. That's why it's labeled with a lowercase c. The side that is labeled 9 is opposite the angle A, so it's usually labeled lowercase a. And the side opposite the angle B is labeled 12, so it's usually labeled lowercase b. In our diagram, the right angle is C, so the hypotenuse, the longest side, is side C. So when we use the Pythagorean theorem, we always want to make sure that we use the longest side, the hypotenuse, as C in the Pythagorean theorem. And of course, it's the same letter here. So if I plug in, I'm going to have 9 squared 4a squared plus 12 squared for b squared, and we're trying to find c squared. Of course, 9 squared is 81, and 12 squared is 144, so that gives us a sum of 225. And we would use the square root to find the value of c, which of course is 15. So the missing hypotenuse here is 15. So when we want to find our trigonometric ratios, we're back to using SOHCAHTOA. Remember, S stands for sine, which is the opposite side over the hypotenuse. C stands for cosine, which is the adjacent side over the hypotenuse. And T stands for tangent, which is the opposite side over the adjacent side. So I'm going to start with the sine for our angle theta, and as we look at our diagram, theta is right here. You might also call it angle A, but the side opposite the angle theta is the side across the triangle, which in this case would be the side labeled as 9, and the hypotenuse is the side labeled as 15 that we just found. Now, if you're unsure, you just have to understand which side is the hypotenuse, and then that can help you in finding the sine. Of course, 9/15 reduces to 3/5, and if the sine of theta is 3/5, then the cosecant, the reciprocal, would have to be 5/3. So then we'll find the cosine. The cosine is the adjacent side over the hypotenuse, and the adjacent side always forms the angle with the hypotenuse. So in our diagram, that's the side labeled as 12 over the hypotenuse of 15, and when we reduce by dividing both the numerator and denominator by 3, we get 4/5, and that helps us to understand the secant, which is the reciprocal, would be 5/4. Then we talk about the tangent. The tangent ratio is the ratio of the opposite side over the adjacent side. So for our angle theta, the opposite side would be 9, the adjacent side would be 12, and that reduces to 3/4, which means the cotangent of our angle is 4/3. So it's pretty easy. You just have to make sure you set up the Pythagorean theorem correctly and then find the missing side. It could be the hypotenuse or one of the legs. And then you need to use SOHCAHTOA to help you remember the sine, cosine, and tangent ratios reduced, and then the reciprocals for the remaining three. Let's try a second example. I'm going to go down here, and I've already gotten it started. We, again, are missing a side, but this time it is the leg labeled A. And we know the hypotenuse, which is 29, and the other leg is 21. So our Pythagorean theorem, we have a squared plus 21 squared equals 29 squared. And if we simplify, we're going to get a squared plus 441 equals 841. And by subtracting, that means a squared will be 400. And then, of course, we take the square root of both sides of our ratio, and that gives us a equal to 20. So our missing side over here would have a length of 20. So then the sine, remember SOHCAHTOA, opposite over hypotenuse, and you need to be looking at the angle theta. And so opposite would be 20 over the hypotenuse, which is 29. And that doesn't reduce. But the cosecant, which is the reciprocal, would be 29 over 20. The cosine is the adjacent side or adjacent leg, 21 over the hypotenuse of 29, which means the secant is the reciprocal, or 29 over 21. And finally, the tangent is the opposite side, or 20, over the adjacent side, which is 21, which makes the cotangent 21 over 20. So some of your MyMathLab problems will be like these first two. Then the next set of exercises, you're actually going to work with the special right triangles. And you can see the special right triangles as pictured, the 45, 45, 90, and they give you the measures of the legs and the hypotenuse like you would have learned back in geometry. And what they want you to do is just find the given problem's trigonometric ratio. So for instance, number 1 is sine of 30 degrees. So in my diagram, my 30-degree angle's up here, and I want the side opposite that angle over the hypotenuse. Well, in that case, that's going to be equal to 1 over the hypotenuse of 2. And that would be the sine of 30 degrees. Now, the next problem asks for the secant of 60 degrees. So I'm looking again at the triangle on the right. My 60-degree angle is at the bottom. And in order to find the secant, I'm going to start with the reciprocal, which is the cosine of 60 degrees. Now, cosine is adjacent side over hypotenuse, and for the 60-degree angle, the adjacent side is 1, and the hypotenuse is 2, which means the secant would be the reciprocal of that, which is 2 over 1, or just 2. Let's go down to cotangent. Cotangent of pi over 4 is really the cotangent of 45 degrees. And let me erase my angle there. And the 45-degree angle is on the other triangle. Now, both acute angles are 45, so you can really look at either. And if I'm going to find cotangent, I'm going to start with the tangent of 45 degrees. And tangent is, of course, opposite over adjacent, and that's 1 over 1, or 1, which means when we find the cotangent, the reciprocal is going to be 1 over 1, or just 1. How about the tangent of pi over 6? So first, we have to understand pi over 6 is 30 degrees. And that means we're looking at the triangle on the right, the 30-degree angle, and tangent is opposite over adjacent. So that means that we are going to take 1 over the adjacent side of square root of 3, but we have to rationalize this by multiplying by square root 3 over square root of 3. So our answer becomes square root 3 over 3. The last one, we've got the cosine of 45 degrees times the cosecant of 30 degrees minus the tangent of pi over 3, or the tangent of 60 degrees. So let's look up to our triangle, and we're going to use the 45-degree angle, either one. The cosine is adjacent side over hypotenuse. So for our angle, that's going to be 1 over the square root of 2, but we'll need to rationalize that. So that really becomes square root 2 over 2. Then we multiply that by the cosecant of 30. So 30 degrees is up here, but we've already found the sine of 30 in problem 1. And we know the cosecant, or the cosecant, is the reciprocal. So that would have to be 2, or 2 over 1. And then we're subtracting the tangent of 60. So now looking at our 60-degree angle, the tangent of 60 is opposite over adjacent. So that's going to mean square root of 3 over 1, or just square root 3. And if we simplify, that means our answer really is square root 2 minus square root 3. We're not going to approximate. We're just going to leave it in its exact form. So that should cover some of the problems you will encounter in 4.3, My Math Lab homework. It's not all of it, but we'll continue on Friday in class with our third day on this section, or third lesson on this section, and then we'll start tying up 4.3. Hope that helps. Have a great day.